Our third presenter today is Kyle Thacker, who is Reservoir Engineering Lead from MEG Energy. Kyle is also featured in one of the first videos that ERA put together highlighting our investments. This was for our Oil Sands Innovation Challenge. You can find the video in the impact section of our website. If you scroll right down near the bottom of the page, you'll see a picture of Kyle's face, and you can click on there and take a look at the video. It's very well done. Today, Kyle will talk about MEG's enhanced vapor technology, eMVAPEX, which is an extension of MEG's gas push technology, eMSAGP. So Kyle, looks like you've shared your screen. Whenever you're ready, feel free to take it away.
Yeah, thanks, Mark. Can you hear me all right there?
I can hear you great, loud and clear.
Perfect. Yeah, so thanks for the introduction there. And yeah, I'm MEG's Reservoir Engineering Lead. I've been managing MEG's eMVAPEX pilot for the last 4 years or so. And yeah, excited to share some information about the project and lessons learned with you all here today. So here's my contact information. If anybody does want to reach out following the workshop, depending on the questions, I may be able to provide some more insights into to what you might want to learn. Quickly going through the agenda for today, I'll start with acknowledging some of our partner support for this project, as well as for the eMVAPEX pilot as a whole. I'll show you the conceptual model and explain how the process works. Then we'll get into some details on the project and the pilot, so that the timeline for the pilot, the goals of this particular project, some of the milestones, and how that was set up, as well as some lessons learned, and then wrap it up with a summary and quick chat about the next steps. So funding support for this project. So we've been very fortunate to have funding support from 4 different government organizations. So Emissions Reduction Alberta, who's putting on this workshop, provided $10 million for this project. Alberta Innovates, $2 million. Natural Resources Canada, $8 million. Sustainable Development Technology Canada, about $8 million as well. And Alberta Innovates and Canada also contributed to earlier phases of the pilot as well. But in total for phase 3 here, we did get contributions of about 28 million, which is very important and definitely helped MEG de-risk this project in terms of going ahead and executing it, as well as help provide funding or employment opportunities, as well as learning opportunities for everybody to learn to better understand this new process, as well as some of the new equipment that was installed for this project. And I just want to also point out that Bruce Strong was also our project advisor with ERA, and yeah, very good support he's provided throughout this project with very good partner and very good questions and technical support as we've progressed through this project. So this slide, I'll spend a bit of time talking about. It's the conceptual model for the eMVAPEX process. So eMVAPEX stands for Enhanced Modified Vapor Extraction. So it's a modified version of Roger Butler's VAPEX process. So the way it starts is we start out with SAGD well. So we have a SAGD well shown on the left here, or SAGD well pair, and a SAGD well pair shown on the right here. So the idea is that you do SAGD until the recovery, the bitumen recovery is at about 30% recovery. And then at that point, there's 2 steam chambers in this picture. And then there's a wedge in between the 2 steam chambers that has started to warm and has some mobility. So prior to any steam injection, there's no mobility. And now that we've got this picture to about 30% recovery, there's some mobility in this wedge here. So at that point, steam injection is reduced to near zero and condensable gas injection is started. So for this project, we use propane as the condensable gas, and the propane does 2 things that the steam had previously done. So the 2 things the steam was doing before was maintaining reservoir pressure, so taking the void space of the bitumen that has been produced, and it mobilizes the bitumen by heating it and reducing the viscosity. So now the condensable gas, the propane, comes in and does those same 2 things. It maintains the reservoir pressure, and it also reduces the viscosity, but in a different way. the propane will mix with the bitumen. A portion of the propane will condense and mix with the bitumen and reduce the viscosity in that manner. So that's why the condensable gas kind of replaces the steam. And when that propane is at adequate quantities but mixed with the bitumen, then there's potential for de-asphalting to occur to improve the product quality of the bitumen that's ultimately produced. The second part of the process is the infill well. So at the time that we start the condensable gas injection, we also drill an additional producer well called the infill well between the SAGD well pairs. And then that well, I'm sorry, that well acts as a sink to produce more oil as well as to recover some of the injected propane. And the final part of the process is since the steam is reduced to near zero, there's a very significant amount of steam that's freed up. So that steam can then be redeployed to new SAGD wells. And what the end result we think is that without steam facility expansion, we could increase facility production by up to 75%. And then corresponding to that, the SOR of the facility could be reduced by as much as 43%. So very significant increase in production potential, as well as reduction in SOR. And then along with an SOR reduction would the GHG reduction, emissions reduction, as well as water use intensity reduction. So very, very attractive in terms of the potential environmental and economic benefits there. So this next slide goes into the timeline for the pilot and where we're at today. So at the bottom here, we have a Gantt chart to show when we were injecting into what wells. So we started out with phase 1. Phase 2 was really a proof of concept. It was only one well pair. Phase 2, early results were good, so that justified us going to phase 2, which is a little bit bigger. So we had 3 well pairs plus infills on either side, and so just a little bit bigger. And then phase 3 is more of a commercial prototype, and it's to expand to more wells as well as add a propane recycling facility. And that came online late 2018, and we got up to 7 wells with propane injection. And this next slide will show the configuration. So this is looking down the length of the well. The green dots are producer wells. These light blue ones are propane injection, condensable gas injection, and the red ones are where we inject steam for SAGD or steam and NCG. So we started out with just AP2. That was our proof of concept. And then we added AP1 and AP3 in 2017. Results were good. So in 2018, we added AP4, 7, 8, and 9. And the reason for having a gap in here and having 7, 8, and 9 separate was a couple. One was to keep these 3 wells kind of isolated and then all starting on eMVAPEX at the same time. These earlier wells were started at stage timing, so the results are maybe a little bit harder to interpret. But having these 3 start at the same time makes that a bit easier, and having them independent. And there was a couple wells in between here that had some liner damage, so we wanted to avoid those. So next I'll discuss the goals of this specific project, and I can give some high-level results as well. The data from this project is largely confidential, so I can't get into too much detail, but I can give some rough insights into how we've done in terms of these goals. So on the technical objectives, we needed to demonstrate that we can successfully continuously inject propane into operating SAGD well pairs. We did that. Our plan was to go up to 10, and we ended up with 7. We want to be able to maintain bottom hole pressure with propane without needing a lot of steam or NCG, and largely we've done that. The propane recovery from the reservoir, very important in terms of the economics, because propane costs money to buy, and if you lose a lot of that into the reservoir, then that makes the operating cost of the process expensive. Our goal is to get at least 75% return to surface, and we're right in that range. Related to the propane recovery is the net propane to oil ratio. So the net propane to oil ratio that's the amount of propane that stays in the reservoir for every barrel of bitumen that's produced. Our goal is to be less than 0.2, and during operation we've been in that range, maybe a little bit higher, and we expect on a cumulative basis, like once we try and scavenge some of the propane out of the reservoir at the end of life, we'll be right in that range or a little bit lower. So we're in that range. I would like to demonstrate an increase in the oil quality, and that's something we're monitoring, but I can't speak to the results at this time. And then demonstrate the propane recycle facility viability and operability, and try and have good runtime at greater than 90%. And for the most part, it's been pretty positive in terms of the runtime. Some of the strategic objectives to maintain or increase bitumen production and recovery relative to our eMVAPEX process. So MEG uses what we call eMVAPEX, enhanced modified steam and gas push. So it uses SAGD, but then you add NCG and infills later on into the life of the SAGD wells. So that's MEG's default technology, and that's really what we're benchmarking against for eMVAPEX. And we're still monitoring the results there and trying to understand where eMVAPEX is going to end up recovery-wise relative to eMVAPEX. A big one here is the SOR. So we definitely want to reduce GHG and water use intensities by reducing the SOR bitumen. When we set up this project, the goal is to be less than 0.7, and during this project, we've been quite a bit lower than that. We've been near 0 for this project, so that's been very, very attractive. And then finally, to communicate lessons learned, technical gaps, and future opportunities. So this next slide, I won't read it. I'll kind of give it a high level discussion just in the interest of time, but just to lay out the milestones. So the milestones for this ERA project were divided into 4 milestones. The first one being pre-project activities, which included the regulatory applications, design for the facility, that type of thing. Milestone 2 was the construction and the commissioning of the recycle facility. And then milestones 3 and 4 were the actual pilot operations. So high level, some of the lessons learned for this. One was on the design. We decided for optimal operability, we wanted to have control of our compressor package from the DCS rather than using a PLC, just to have a better integration with the rest of our facility. Not having the proper control narrative in order to set up in the DCS, that led to compressor delays. So there was an action to ensure that would be part of the package that's provided by the EP contractor. In terms of the recycle facility and the construction, skids and modules were shipped with some known deficiencies, and that didn't all get communicated to the guys on site. So there was a follow-up then to make sure that any scope of work that's getting pushed to the construction site is formally communicated. Another one in terms of construction and walkdowns was some of our operators weren't included in some of the walkdowns of the compressor package itself because it wasn't assembled at site. So there was an action there to include the operators that are going to be ultimately running the facility at an earlier stage of the process, not just the end. And one during the operation that we learned was that there's quite a bit of produced gas production associated with this process. So propane exists mostly in the gas phase. So the amount of gas that was produced is relatively high. And what we found was some of the wells, we were having some gas coning issues, and we installed casing gas meters on 2 of the infill wells to monitor that gas production live and better dial in and optimize the production. So the live meters definitely helped, because otherwise we'd be relying on the wells going through test separator, which only happens about once every 2 weeks on this pad. And finally, a quick summary and next steps. So the goals for this project were to complete the pre-project activities, which included financing and securing financing from our partners, regulatory approvals and design, construction and commissioning of the recycle facility, operation of the expanded pilot. I definitely wanted to acquire all the data and work towards meeting the objectives that we outlined previously, and confirm the performance on the pad scale, including the propane recycle facility viability and operability, and then potentially make a commercialization decision. So the project has successfully achieved most of the stated goals. The majority of the reservoir performance metrics were successfully achieved. However, we are continuing piloting activities in 2020 to continue to evaluate the performance, including a strategy to try and maximize the recovery of the retained propane in the reservoir. We definitely want to try and get as much of that back as we can, just because that propane does have value. And we are looking at making a commercialization decision in the near term, hopefully by the end of 2020 here. But otherwise, yeah, we're just in the later stages of the pilot operations and continuing to acquire data to learn as much as we possibly can and have as much confidence in the process as we can prior to making any long-term decisions. But that's all I had. Thank you for your time, everybody.
Excellent. Thank you very much, Kyle. Once again, I look forward to hearing more in just a few minutes now.